Thank you for joining. Thank you for joining. My name is Christine Dallinger, and I welcome you to today's NEWBITS webinar entitled Unveiling the Potential of ATIS Applications and Services in Europe. Thank you all for being with us today. Today's webinar is in fact the first in a series of 4 webinars that will be delivered by experts from the ATS project NEWBITS. These webinars have been organized with the aim to share unique insights from a novel network-based approach to craft and design new business models for ITS. So just a brief technical announcement for today. If you have any questions, feel free to write them in the chat box and we will collect and address them after the presentation. Of course, you're invited to send further questions that may arise later to us via email as well. And also you will find recordings of this webinar on the NEWBITS project website later on. So what will you learn in today's webinar? You will first of all have a chance to get to know the NEWBITS project. And then second, the webinar presents results from a conjoint analysis, a statistical marketing research technique, discussing which elements of an ITS service are key for the potential user of the service. And third, you will gain novel insights from a market analysis from selected ITS markets in Europe. So in particular, the webinar discusses how to unveil the potential of ITS services by presenting detailed information from 4 explored ITS applications and services, which were analyzed within NEWBITS. And those you can see here. All 4 ITS services presented are real close-to-market solutions. They have been carefully selected and validated as representative for the current ITS market in Europe. They cover all ITS market segments and different transport modes, such as road, rail, and inland waterways. So the 4 ITS services discussed comprise 1, a carpooling service in Spain, which is an example of the sharing economy collaborative consumption, where the platform matches users to vehicles to reduce unnecessary trips. Second, we will have a look at an urban traffic control solution in Italy, which is an example of the Internet of Things, Smart Cities CITS platform to monitor drivers' behavior and forecast. Third, we will look at a synchromodal ITS container tracking service in the Netherlands, an example of how smart data analytics and real-time information can improve the logistic chain. And fourth, a predictive maintenance solution for railway safety in the UK. This is an example of big data analytics and visualization service of infrastructure assets to avoid unplanned repairs. Now, this webinar will be delivered by experts from Otelio and ATOS, and it's an honor for me to introduce them to you. Viara Boykova from Otelio, she holds a degree in economics and philosophy from London School of Economics and is currently working as a senior economist at Otelio. She has provided advice to public authorities in the UK and Europe, and since 2015, she has been contributing to various Horizon 2020 projects. And she's also associated with the Global Policy Institute based in the City of London, where her focus is on global economic policy issues. And then we will move on to Ivan Zaldivar. He holds a degree in computer engineering from Deusto University. And since 2008, he has been working at ATOS as a project manager in public administration sectors. And since 2012, he moved to the Research and Innovation Department for ATOS Spain and holds a strong focus on energy and transport markets. He's also involved in several projects for the European Commission. So welcome again, and with no further ado, let me hand over to Viara.
Many ITS projects have been launched without a full evaluation of the existing market conditions and customer groups, or no clear business models explained. And as a consequence, there are a number of multiple projects funded simultaneously from different institutions without any coordination of the results, which leads to difficult cooperation between private and public partners, or even to the creation of competing technologies. We have new elements in the approach of the NEWBITS applied in 4 European member states. And these new elements are derived from the unique characteristics of the digital goods and markets. And as you know very well, we have observed for the last 2 decades a digital transformation in our local economies that changes the life in the cities, creates new markets that we never imagined before, and distracts many sectors of the real economy, such as the health, transportation, finance, education, and agriculture. Policies that have been implemented to support our real economies during this transition tend to focus on the establishment of innovation networks, access to finance, data use, and security of data, but pay less and less attention to the transfer of knowledge and data, and also to how the data has been analyzed. However, companies have already been taking advantage of these new opportunities and strategically develop new business models that create additional business value by extracting refining resources than other companies which do not utilize data properly and do not use these opportunities. And moreover, what are these opportunities that companies benefit from? I will mention only 3. First of all, it is relatively easy to establish networks. As a result of the end-to-end principles of the internet, actually users of products or services are free to design their own networks through different channels, social networks, mailing lists, hyperlinks. They can establish well-developed communities, not only locally, but also globally. The second opportunity is all this establishment of networks is facilitated by the so-called platforms. And we all know about the platforms. They can put together different parties, expand the interactions between different parties, which represent individuals, local communities, users of products, services, businesses, and governments. And the third opportunity is the value mobility. As a result of the global reach of internet, nowadays value can be created, can be transferred, regardless of borders or geographical territories. Considering all this, let's look and return to the NEWBITS approach, which we implemented as a result of the use cases in 4 countries: Spain, Italy, the Netherlands, and the United Kingdom. Actually, the overall approach of our project aims to set up a systemic way of establishing an ITS network and shaping its business model. It includes 3 major pillars. First of all is data gathering and analysis. The second pillar is the NEWBITS network platform. And the third pillar is shaping and reshaping the business models. With the first pillar, all the data we collected at the beginning of the project, or in the first 3-4 work packages, we collected, analyzed, and this created the foundations for the value network modeling. The NEWBITS consortium developed a tailor-made value network analysis and used the business ecosystem concept in order to understand better how the stakeholders interact in an ITS network in Europe, and where exactly the value lies in these networks. With the second major pillar, we are setting up a NEWBITS network platform, which gives a chance to the stakeholders to interact. It actually provides them with opportunities to exchange knowledge, but also gives a chance to the consortium to receive feedback from the stakeholders. So the network platform is not only about the networking, but it also gives some more visibility to the communities of interest and provides more feedback. So for us as a consortium, it's also a feedback mechanism. And the third pillar is based on all this that we receive as a data, as conclusions from the analysis and the feedback from the stakeholders. We create business guidance for the ITS networks and write policy recommendations for the policymakers. The most important thing for us is to understand the needs of the stakeholders. Therefore, we encourage stakeholders from the ITS industry in Europe to register on the NEWBITS network platform, which gives them incentives to expand their interactions and design their own networks with the communities of interest. Thank you very much for your attention, and I pass the floor to my colleague Ivan.
Thank you very much, Vera. I'll put my presentation on. You should be seeing it right now. Okay, in NEWBITS, we have based the research in a market analysis and a stakeholder analysis and a conjoint analysis. Let's see an overview of each of them. The market analysis is grounded in a segmented analysis of the supply and demand sides, identifying the target market for each case study. A pastoral analysis was performed categorizing the most relevant factors influencing the case studies, and then complemented with the SWOT analysis. Additionally, a competitor assessment classifies and selects the main competitors for the case study. The stakeholder analysis starts with the selection of the most relevant stakeholders and breaking them down in the main characteristics and interest. Each stakeholder is then assessed by its importance and influence, and the relation dependencies are then mapped, creating a visual diagram explaining the value flows and interrelation among them. As a final result, and based on this information, the resultant value chain is depicted. The other fundamental research area is a conjoint analysis. You can see a very basic example of the initial steps of a conjoint analysis in the figure at the right, in this case using a smartphone. Conjoint analysis is a quantitative method in marketing research, basically consisting in breaking down a product or service in its main attributes and levels, designing different profiles based on these attributes and levels, and using these profiles in a data gathering process where the preferences of the end users are then extracted using statistical and mathematical methods. The ATIS market is rapidly evolving. In this slide, we can see some estimation and forecast coming from Transparency Market Research about the ATS market, where we can see it can double its size by 2024, growing at an annual rate of 12.7%. ATMS, standing for Advanced Transportation Management System, used for traffic management and control, accounts for the largest revenue share of the overall market, and ATPS, Advanced Transportation Pricing Systems, including things like electronic toll collection or congestion pricing, are also expected to experience a global increased demand. North America and Europe are still the two more important geographical segments, although Asia Pacific and South America could experiment the highest growth in the next years. Here we can see some of the most important trends in mobility and ITS. Connected car technology was intended primarily to improve safety, recognizing and alerting drivers of dangerous situations. But today we can understand connected car going very closely in hand with big data, in terms of data set from millions of sensor-equipped vehicles, leveraging and compelling new services. In fact, connected car services are approaching a market inflection point. Some forecasts state that the original equipment manufacturers' revenues from the monetization of automotive sensor data are expected to reach 700 million, with an annual growth rate of 46.8%. Soon, we can see a shift in the revenues from product sales into monetization of fleet-based assets. This is already happening today. A very clear example is in the Netherlands, as a first nationwide implementation in the world, assessing, calibrating, and replacing or upgrading the traffic sensors over the last years. Today, the Dutch National Data Warehouse is receiving 10 million traffic data updates per day. The traffic sensors deployed in the Netherlands can be considered as the most advanced technology in the world. Going back from the Netherlands use case to the general, all these datasets come from the billion of devices, not only deploying cars and roadside units, but also considering things like smartphones. They can be used in improving applications such as parking and traffic management, or even enable new use cases such as user-generated maps or autonomous driving. Speaking about autonomous vehicle, even when we can consider it's not so close to us at the moment, it's still gaining momentum, and we can highlight some examples to demonstrate the relevance and impact of this technology. Recently, a funding competition in the UK has allocated £30 million to create 2 permanent self-driving test sites, establishing a goal to deploying fully self-driving vehicles onto the roads by 2021. This is not an isolated case. Oslo in Norway is already examining several future scenarios to develop a model for driverless transport. In North America, Ohio has just authorized an executive order allowing autonomous vehicle testing in any Ohio public road. China has already deployed in its first demonstration autonomous ride-sharing fleet, and Australia announced last year its ATIS class license, establishing the next generation of connected and autonomous vehicles to be introduced into the Australian market. Mobility as a service, the on-demand economy and socio-economic shift defining the way we consume, is going to impact heavily in the market, especially boosting the development of autonomous driving. The United States will lead the initial deployment of an early adoption of producing autonomous vehicles as early as next year, 2019. Europe and China will follow in 2021. Today, the predictions are 33 million autonomous vehicles sold in 2040. These are the NEWBITS case studies. As my colleague Christine already introduced them, the following slides will present some relevant data in order to illustrate the results from the analysis. For the case study one, this slide provides some numbers about the data we gathered for it. The campus of the pilot site accounts with 46K students with 6K employees and a very low index of occupation with 1.11 passengers per car. The daily average numbers of vehicles entering and leaving the campus and parking areas are nearly 40K. The solution cost is 8.5K euros. So we have established the target market in Spain, extending the service to other campuses and industrial areas, although the solution is potentially scalable to any other city or region in Europe. Here we can see some of the results of the conjoint analysis, in this case the attributes importance. The service was decomposed in 6 attributes, and as you can see, end users gave the most importance to the access to a dedicated parking space. A communication feature such as messaging application integrated in the service and the identification of users were also perceived as very important. This information, along with the level utilities, was used in order to perform some market simulation, revealing that the access to parking space was by far the most important feature and messaging functionality, very important for younger segments, was diluted by users' identification as we move to older segments. As a summary, we can conclude that the solution is applicable to other campuses and industrial areas. End users have a high resistance to share a vehicle. The carpooling service should offer as many benefits as possible, such as parking space, communication, security, etc., in order to break that resistance. And dedicated parking space highly increase the service acceptability. For case study 2, we can state that the private cars in Verona are nearly 160K, with 1 car per 1.6 inhabitants. The average increase of cars per year is 400. The extra travel time due to traffic congestion is 90%, this meaning 90 minutes per day or 74 hours per year. And the solution provides a reduction in travel time of 28.9% and a reduction in pollution of 14.4%. The solution cost was divided in 33K euros as an initial investment and 20K euros as an annual operation and maintenance cost, and it was estimated for a simulated medium-sized European city. For the conjoint analysis, the service was decomposed in 5 attributes, and end users gave the most importance to the information type. In this case, the service provides 2 different types of information. The first one is gloss, stating for green light optimal speed advice, or the speed the driver needs to maintain in order to catch the next traffic light in green, and TTG, time to green, informing the driver of the time left until the traffic light switches to green. Technical aspects, such as the operating system for the device or the notification type, information provided in a visual way or via voice notification, were also very valued by the end users. As a summary, the conclusions reached are the solution is applicable to nearly 45K traffic hotspot in European roads. A traffic light assistance service is still perceived as an intrusion into the driver's experience, so end users prefer information they can manage directly. Technical aspects, such as the operating system or the way the information is delivered, are quite important, especially for younger users. Some numbers about the case study 3. The inland terminal capacity is 145 kTU per year, TU being the 20-foot equivalent unit, used for describing the capacity for container. The warehouse operator number of containers ranges from 8K to 12K TU per year. The C per number of containers is 1.8 kTU per year, and the solution provides a travel time reduction of 2-3 days, and the benefits coming from this time reduction ranged from 7 to 25 euros per TU. The solution cost, with a 600 key average, range from 300K to 900K based on the actors included in the supply chain. The conjoint analysis divided the service in 7 attributes, including the coverage of shipments, ranging from 70% to 95% of the total amount of containers. Communication, ranging from simple messaging to include relevant documents such as customer documentation. Notification of deviation, ranging from a daily report to real-time information. Container condition, including manual information or sensor information. Container selection, allowing to select which containers are going to be monitored by the service. Tracking truck transport, providing tracking for the last mile transport performed by truck, or either the alternative last-minute full truck transport for the inland shipping, and the price per container. In the picture, we can see the price, the tracking truck transport, and the notification of deviations are the most important features. The market simulations reveal that the capacity of tracking the transport in the last mile is highly appreciated by the end users and should be prioritized. As a summary of the conclusions, we can state that the logistics change companies, mainly small companies, are in great need of tracking services. Service monetization per container seems to work very well for small companies, but providing another monetization model will help the acceptability for medium and big companies. The perception of the utility of the information provided by the service varies a lot depending on the role of the person within the company. The service will increase the acceptability being offered as a bundle and configuring it depending on the user needs. Finally, the case study 4, we can see here some numbers. The train services per day is 6K. The annual rate passenger journeys are 246.5 million. The solution provides a reduction in maintenance cost up to 12% and increased network availability up to 20%. The solution cost is 125K euros. The conjoint analysis divides the service in 5 attributes. The value for money, representing the value obtained by the train operators providing the services in a better maintained infrastructure. The journey reliability, diminishing the delays in the services. Safety, measured in the reduction of accidents. Lower cost for the infrastructure, and reputation, translate in an increase of passengers or freight for the services. The increase in safety, especially for the information provided by the service about the cause of an accident, was the most valued feature. The market simulation revealed that the service has a very high base acceptability, in this case even further increased by the absence of cost in the pilot case. Since the service has been already deployed in a real environment, providing reliable estimation about the benefits could be a good marketing strategy. As a summary of the conclusions, a predictive maintenance service has a high base of acceptability given the great benefits it can provide. Security information in terms of reason of an accident highly increase the service acceptability. A trial approach could work well as a market strategy given the low cost of deploying the service with reduced functionality and the potential benefits obtained. The general conclusion is ITS is a growing market which will experiment many changes in the coming years. Mobility as a service is changing the way the market understands mobility, and new mobility services are pushing providers to rethink about their existing business models and explore new ones. NEWBITS case studies are representative of the current ITS landscape at the moment, covering several transport modes and are aligned with the market trends. The conclusions reached by the NEWBITS case studies market and conjoint analysis are a perfect basis for the establishment of new ITS business models. If you want to obtain more detailed information about this, you can go into our website, especially accessing two of these documents, D3.1 Market Research Analysis and D3.3 Conjoint Analysis on the case study. This is all from my side, and I'll pass the floor again to my colleague, Christine.
Okay, thank you very much, Ivan. I will reconnect the screen. And yeah, thank you all for joining us today. If you want to stay in touch with NEWBITS, you can access further reports on our project website. You can sign up for our biannual newsletter. You can follow us on LinkedIn and Twitter. And most importantly, you can join the NEWBITS network platform. And with this, I would also like to draw your attention to a second webinar in the NEWBITS webinar series, which will be held tomorrow on the 26th of June. And the topic of this webinar will be communities of interest, which are flexible accumulations of different stakeholders which share common goals, interests, and environments. And we will show you how communities of interest can create momentum to drive the development of new business models for intelligent transport systems. So we're looking forward to seeing you there, and thank you for joining us today. Goodbye.